and welcome to my demonstration of the PSO implementation that I did for pattern recognition on speech. Just going to run you through how to actually run the program. I do have another video that I've posted up that explains a bit more about the data that I used and how the data was structured, and just a run through on the different classes and what each of the classes do. But just for this video, I'm going to keep it brief and just quickly run through how to actually start up and run the program. So it is very simple. Everything has been described pretty clearly of what to do. It doesn't have a GUI, it just runs on the console, so you can run it from terminal, or you can run it through Eclipse like I am right now. So yeah, firstly you want to basically choose between one of the 5 words to set as a search criteria for the swarm. Now you can choose from either the word hello, my name is, and Usman. So those 5 words, each of those words have 15 different models. And let's start with, just going to type it in here. I want to choose the word hello, and now I need to put on a number at the end, like all of these examples have over here. So either I want to put hello 0 on the end, or I can put 0, any number on the end, up to 14. So I'm going to choose, let's choose 0. Let's start with the first one. Now I'm going to press enter. It does allow you to change the parameters there, but I have set them to default. I just felt like this gave a very good convergence, and it just seemed optimal to me to keep it at the swarm size of 300, and that may seem like quite a bit, but it's 300 across 20 dimensions, so there's 15 particles on each dimension. The max iteration is set to 100, and the program here, it says 10 times. That just basically means that the program itself as a whole is going to run 10 times, and then we're going to compare each of those runs of the program against each other in our results. So I'm going to keep it the same, so you can enter any number in. If you enter 0, then that will allow you to change the parameters, so I'm just going to put in any number there. So now it's basically run, and what this is giving us here, it does describe to you what this is. Okay, so on the first run, we can see that 90% of the swarm, so the 90% of the 300 particles, and this is taken into account across all dimensions, 90% of them converge to the word hello, and 10% converge to the word Usman, and 85% recognize it as being speaker 1, as there are 5 different speakers that all of the data is modeled by. More on the data sets I'm going to describe in the other video, but for here I'm just going to quickly go through the demo and what this all means. And then lastly, about 10% and the 4% over here, they are of other speakers, but the majority have converged to speaker 1. And then you can see it's pretty much similar thing across each of the runs. These are basically, we run the whole thing again for the second time. You got a better conversion to speaker 1 there, and slightly lower, but you know, you run it a few times, you do get 100% sometimes for the word. Now over here we basically have got a summary of all of those that you choose there. You could do about, like, let's say you run the program for 100 times, and then it will even give you a percentage of across the 100 times how reliable is it, and how reliable are those convergences. So yeah, we're looking over here about 89% of success towards the word hello across all 10 runnings of the program, and not many for my name, and is name barely has any, just 0.1%. We've got quite a bit there, 5.8%. So you can see there's a lot of similarity between the word hello and Osman, and a lot of them, uh, a lot of convergence towards the word, the speaker, the first speaker who spoke the word hello. Um, so yeah, I do give a brief description about that data there. And also you can look at the data text file of the MFCCs by just looking through the source file that is provided with all of this. Next, I go on to basically break down each of these single runs, and sorry, not each of the single runs, but breaking down the dimensions, as each of these runs represents 300 particles going through the whole PSO algorithm and doing it across 20 dimensions. So now we can look at a summary for all those runs towards on each dimension. So looking at it in more detail. If you did want to just look at one run, then you could just adjust the parameters above here and change the running of the program to 1, and then that would allow it to just run one time, and then you can take a look at each dimension, and that would just be for the one iteration. But this is just giving you the averages of multiple runnings of the program. So you can enter a number between 1 and 20 to look at whichever dimension. So I'm going to look at dimension 1. On dimension 1, you can see a little table printout here. We've got 75 particles at this coordinate here, 73 there, and 1 over here. Now, and there's 1 there as well. I did say that there are only 15 particles on each dimension, as you install a swarm size of 300 over the 20 dimensions. That means there will be 15 particles on each dimension, but because we ran this program 10 times, it's giving us the total number of particles that have gone to that coordinate over the 10 iterations of the whole program. So that basically gives us 15 particles per dimension, times that by 10. So we're looking at about 150 out of the 150 over here. So that is pretty much all over here. So these three columns here, that makes 75, and that makes 75 there. So all 150 particles on dimension 1 did manage to converge to the correct word, which is hello, and hello is represented by these 3 columns, and my is represented by these 3 columns, and so on. Each of these across the y-axis basically represents each of the speakers. There is more on that in the other video, which does describe more about the data, so I won't go into it too much. I can take a look at another dimension there. Looking at dimension 20, we do see 120 particles converging to the word hello, but then you do see, like we were saying before, the similarity between the word hello and Osman. So we do see some cluster forming over here in under Osman, and that is for 3 different speakers. So speaker 1, 1 particle, majority of them. For speaker 2, the word Osman is very similar to speaker 1's, which is 0, speaker 1's hello. So we've got 27 there and 2 over there. So that makes a total of 30 particles there, and then the other 120 over here. So we can obviously see, if I did simulate this in a GUI, you would see 2 clusters forming, but a dense population would be in fact on the 120 under the correct solution, which is the word hello. Again, let me just quickly do another one. There's 15, dimension number 15, and again we see a majority of the majority of the particles over there, and then we do see 13 over here, 1 over here, 1 over there. So you could see a very small cluster forming over here. That could be another local minima like we saw in dimension 20. But like I said, a majority is in fact in the correct solution space. Now, from here, that's pretty much it. You can carry on looking at all of the dimensions. So dimension 1, 2, 3, 4, 5, 6, all the way up to 20. And just take a look at each dimension. And like I said before, if you did want to just look at one iteration of the entire program, then at the beginning you would change the parameters, keep them at 300, I recommend. And iterations, if you would like to increase that, but then you wouldn't see clusters and you wouldn't see any convergence happening. So I feel like for demonstration purposes, 300 and 100 was good because it allowed me to show you how the particles are moving through the space and how they may fall to local minimums. But I do know that if I do increase the iterations, then all the particle size, I do expect them to fully converge to the correct solution. But like I said, if you do want to just watch one run of the program, then this is what you would want to change, and you can do that by when running the program. You simply, which is actually something I could actually demonstrate to you right now. So I'm going to end it. Just do a quick little demonstration on how to just run the program one time instead of doing it 10 times and comparing the averages. So let's do hello again, hello 0, and I do want to change these parameters, so I'll put in 0, and now it lets you choose a number of runs. So I'm going to just put down 1 there. Swarm size, let's keep that at 300, and the iterations at 100. And now it's basically just run one time, even though it does kind of show it twice there, but that is just one single run. It must have just printed again, but it's run only one time there. And as you can see, there is no need. This is just the mean percentage, and this is mostly just to show you the average over all runs. But as you can see, it's exactly the same as above, and that's because we've only run the whole program once. And then yeah, you will carry on to take a look at the dimensions, and this is just for one run. And as you can see, there are only 15 particles on each dimension now, and that is because we only are running the program once. So that is the demonstration there. I hope you enjoyed it. I hope I've done the right things here. And there is a lot more detail on this in my report, but I have posted another video if you're interested in looking at it. But it has been quite a while of me talking, and I know you wanted me to keep this video nice and short, so